So yeah, we'll start in around 5 minutes. We'll start at 3 p.m. And here's a poll for you guys to use to answer the first question. If you don't know how to spoiler. I will go over in about 3 minutes. Dropboard PDF. We'll start in about 2 minutes. This is gonna be a long one because it's all of Unit 2 instead of just like one small topic. So this is more like a AP lecture, like you'll see in April, May. So because it covers all of exponentials and logs and sequences. So the winning answer right now is D. So we'll go over it. So it says it gives you a polynomial which is p of x is equal to negative x squared times x minus 2 times x plus 3. And it says where is it less than or equal to 0? And if you remember, you're supposed to use sign charts. That's the easiest way to do this. And it's already factored for us. We have our 3 zeros. So we have 0, 2, and negative 3. And then from there, we're going to set up our sign chart. We're going to have 0, negative 3, and 2. And then we're looking for where p of x is less than or 0, or this is also where values are negative. So we're going to plug in some values. We're going to first plug in, let's say, 1 for this range. If we plug in 1, we would get negative 1 squared. 1 minus 2 would be negative 1. And 4. So this would come out to be negative, negative, and positive. These two negatives would cancel out and be positive. So that means this would be positive. From there, we'll test this one, 3. And if you plug 3 in, you would get negative, positive, positive, or the multiplication would be negative. From there, let's plug in like negative 1. This would still be negative because the square will make it always positive and a negative will apply. The next one will be negative, and then positive, which means this is also positive. And then finally, you would plug in maybe like -4, which will still be negative, negative, and negative. So these two negatives would cancel out to a positive, negative, so it'd still be negative. So our interval would be from here and to here, which would be correspond to B. Any questions about this review question from either one? And you use like what, multiplicities? You could, okay, so we could use multiplicities, so let's try that. So we have a full power of 4, right? Because we have a degree of 2 here, a degree of 1 here, and a degree of 1 here, so a total of 4. So we know it's gonna go up, or it's gonna, both ways are gonna go up, or both ways are gonna go down, right? From there, we have negative x squared, so that means a point at 0. We have 2, so this is 2. And then we have -3. 1, 2, 3. So, and it says this is negative, so that means they're going to be going down. So it would look like this. So if you're going to use multiplicities and end behavior, you would also get -infinity to -3, because that's where it's less than or equal to 0, or 3 to infinity, or 2 to infinity. You try to do the work on paper or on like even like a whiteboard like this if you don't have access to paper. If you're on your phone, you could use Notepad, etc. Multiple ways to do it. Alright, so we'll go straight to it. This is prepared by me. It's led by Lance. 5 is a volunteer student run initiative with 100 plus volunteers and 10,000 combined volunteer hours. And consider checking out 55.org for additional resources and practice exams. You can also check out our Insta, our TikTok, and our website. And if you would be interested in applying, I will give the link at the end of the lecture. Yeah, as long as you're qualified, so there's 4 teams: website, RST, outreach, and survey and FAQ. So website develops the website, lecture hosts these lectures and makes articles, materials creates materials, outreach does like post on the Insta and TikTok, and survey FAQ, the best example will be looking at the stats doc. And if you want more information, there's information on the 5 YouTube, which has past lectures and a frequently asked questions thing. And this is from last year, so the people who attended lectures, as you see, most of them got a 5. So, fun fact: 73% got a 5, 90% got a 4. So, and no one got a 1. Yeah, only one person got a 2. So 98% passed. So our first topic is changes in arithmetic and geometric sequences. And so our 2 formulas for this topic are an is equal to the first term plus n minus 1d. And this is for any term, and you can say it's am plus k minus md. And they have a common difference or a constant rate change, and they're mostly like linear functions, but they're not continuous. So a linear function looks like this, but this would just be like just dots. And it stays constant, so slope stays the same. So let's try number 3 first. And the recursive formula is not tested on the AP exams, so you don't need that. So Yeah, we'll be covering inverse functions like when we get to that topic. So don't worry, we'll cover all of exponential logs today. And if you can't stick for the entire thing, the rest will be posted on YouTube. So so I'll give like a minute or two for both. A minute for this one and a minute for this one. You could all say hi YouTube, but it's not. Discord isn't being shown on the YouTube. Only this main screen is. Yeah, exactly. You forgot how to do arithmetic sequences. You'll learn in a sec if you don't remember how to do it. Oh yeah, and fill out the lecture feedback form as well. Well, you got it? Bet. So for this one, we will be using this formula, or the AK equals AM plus K minus MD. Pretty much means you start at a certain term and you end at a certain term. So for this one, we're gonna say we're trying to find first AN. And to find AN, you start with 8, 3, so we know our third term is 8, and our common difference is -3, so we're going down by 3. So that means our second term is 11, and our first term is 14. So AN is equal to 14 plus n minus 1 times -3. And now we can plug in 12 to our equation, so A12 is equal to 14 plus 12 minus 1 times -3, which would make 11 times -3 plus 14 equals A over 12. A over 12 is equal to 14 minus 33 minus 33, which means A12 would be equal to -9. Oh wait, I missed. Not then, never mind. So yeah. Does that make sense? And if you wanted to use the other formula, you could say A12 is equal to, you start with 8, because we would say AM plus K minus M D, where this would be 3. So this would be 8 plus 12 minus 3 times -3, 9 times -3 plus 8, which would be also equal to -9. So there's two ways to solve this. Does this one make sense? Before we go into the next one. Point slope form. Yeah, you could also use point slope form, but try to use these equations for this example, because those are two given on the CED. Okay, I'm gonna guess there's no questions, so we'll go to the next one. So now we have another arithmetic sequence, but now we have more terms. There is not a formula sheet for precalc, correct? So we have 2, 3, 4, 5, and 6. So we know our sixth term is this, and our second term is this. So we can go 1, 2, 3, 4. So we know we're doing our common difference 4 times. So we could say 4D plus our original equals 9. So that means 4D is equal to 2. D is equal to 1/2. And then from there, we can make our AN equations. So we need to find A1 though. So we're going to go back 1, which means we're going to add 1. So now we're going 7.5. No, wait, 6.5. 6.5. So we have our AN now. So we have 6.5 plus n minus 1 times 1/2. And then from there, we just plug in 24. So that would be 6.5 plus 24 minus 1 to the 1/2, 23 to the 1/2 plus 6.5, which would be 18. That should equal 8 to 24. Any questions about this question? Example 4. How did I get D? I didn't get a letter. It's all whole numbers. So example 2, I will give around like 2 minutes, so until 3:14 in my time, so 2 minutes, to determine if it's arithmetic, and if yes, identify the common difference. So, and remember to spoil your answers, so put this on both sides of your answer. Example 2 stumps you. Yeah, you're just trying to find out if it's arithmetic. So is it pretty much a linear, and like this? You're just trying to figure out if it's linear. You're not trying to find which is the right answer. It's like these are all separate questions. These are all separate questions. So for example, this first one is not arithmetic because it's n squared. So it's more like quadratic, which isn't arithmetic. And the next one is yes, and the common difference is -2 because it models a linear equation. 3 is a yes, and the common difference is a 5 because it adds 5 each time. And finally, this would be a no because it goes from positive to negative. So this would be subtracting 3, but now you're adding 5, and then you're subtracting 7, adding 9, which is an arithmetic. So next is the geometric equations, which is just an is equal to 3, so the first term times the common ratio. You pretty much just put these two bars, the horizontal bars, on both sides of your answers to put the blur. Yeah, or the absolute value symbol, if you want to say it like that. And your two formulas for this would be Gn is equal to the first term times Rn, or if you start with a different term, you would say just R times n minus k. And note, these are more like exponential functions, except they're not continuous. So if you had an exponential function like this, now it's just like this. It's just points. And they always increase by a largest amount each time. And the percent increase stays the same, or it's just your R value. So let's try number 7. So this would be number 7, this top part. This is for number 8. Let's try number 7. So first find an expression for g of n, and you use that expression to find g of 4. Alright, I'll put the formulas in the chat, maybe that'll help you guys. You don't get formulas in the test, but for now, while learning it, it can help you guys. Yeah, or you can use an Nimity's formula. That also helps. It is. IVP, it is very helpful for these lectures. Maybe I'll send a picture of how it looks when I do a lecture later. I see. I thank you for spoiling it after, but fine. So for this one, we're starting with g of 1 is 12. So our first term is 12. We need to find g of 0 for our equation over here. So, and it says our ratio is 2. So we're going to go back, which means it's 6 because you're dividing by 2. You're dividing 2 if you go backwards, multiplying by 2 if you go forward. So you could just keep going like 24 and so on. Or we can use our equation. So we're going to use our equation. Our first term is 6. Our ratio is 2 times n is equal to g of n. And then we're going to plug in 4. So this would be 6 times 2 to the 4, which would be 6 times 16, which would be 96. Any questions about how to, for example, 7? Yeah, sequences. We don't need series. There's no series for this. There's no questions. We'll move on to number example for drawing 5. Question about drawing 5. Do we have completed the AP exam previously, or is just doing very, very well in the class in general? Yeah, you need a 4 or 5 on the exam. So several terms of this equation are shown. So if you can't see this, this starts at 8. So you're finding expression for g of n and finding an expression to find g of 10. So I'll give until 3:20-ish. These are, by the way, these are all questions from like Brian Passwater. So thanks, credits to Brian Passwater for most of these questions. So for this one, we have our starting term, which is 8. So that means it's going to be 8 times. And if we go to our next term, we're going to 4. So that means we're multiplying by 1/2 to the n is equal to g of n. And then from there, we're saying n is equal to 10. So it's going to be g to the 10 is equal to 8 times 1/2 to the 10th. Or if we simplify that, that would be 2/3 times 1 over 2 to the 10th. These would simplify to 1 over 2 to the 7th, which simplifies to 1 over 128 to find g of 10. And Thankful Gaming YT, the only mistake you made is it should be 1/2 because you're going down. You're getting smaller instead of bigger. Yep, this is why I do math on paper or on a whiteboard. That also works. So, yeah. And now we have like a few application-based questions. So this is similar, but also a bit different. So now we're going to be using this equation. The gn is equal to gk times r to the power of n minus k. I think someone had asked about this. I would assume so. I'll zoom out so you can see more. Okay, for both 2 and 5, I will give until 3:24, so about 2 minutes. I think it depends on the exam, but I think most of them have 4 now. Like stats, stats still has 5, but CSA has 4. Precalc I think also has 4. Oh, let's get poll. You have to put no space in between the thing. That's for both. This would be 2. This would be 3 on the poll. So help people out with their answers. You just answer the poll if you want to. Yep, and now you got the spoiledness. Okay, looks like a few people have answered the second one, so we'll go over that one. So for the second one, it's asking us to find the nth term of the geometric sequence. So if we remember, we said we want a of 0 to be equal to the y-axis, because that's how we did it over here as well, and that's why we said 8 was a of 0. So we want to, let's look at each term. So it says 9 times 2 to the third. That's not on the y-axis, so we're going to eliminate that. Next, 6 times n minus 1, that just brings us to over here, so nope. 9 times 3 to the 2 n minus 1, that is on there. It is on the y-axis, but we don't want it to be 3 over 2, because that means it would be increasing. But our function is decreasing. And then finally, that leaves d, because it would be n minus 3, so that means we would be on the x-axis, on the y-axis, and we would be decreasing, so it would be d. I see a few people have answered number 5 or 3. And for this one, we would say a over 4 is equal to 30. and because that says the fourth row, and it says it's an arithmetic sequence, and it says A8 is equal to 54. And then from there, we're gonna figure out how much is the common difference, which means we would have 4x plus 30 is equal to 54, because we have our fourth term, which means we've done the common difference 4 times, and we've had some initial value plus that. So we're gonna go until 54, which means 4x is equal to 24, x is equal to 6, which means our common difference is equal to 6. And then from there, we're gonna find a1. We're gonna find a0 actually. So a0 would be 4 times 6, so 24. So we're gonna be subtracting that from a4 to find our initial, so that would be 6. And then it would be a0 plus, and we're going to the 10th row, so it would be 10 times 6, which would be 66. Any questions about that? So for 2, pretty much what you're doing is you're looking for when it's like equivalent to the y-axis. Because remember, we said we wanted to start at g0. So pretty much if we do this first one, we're starting at the first term. Or we need a -1, so that means this doesn't work. For this one, it does the same issue, that we're only going to 1. This one does meet those requirements, but it's 3/2, which means it'd be increasing. And this one meets the requirements because it's starting at 3, going back 3, and is decreasing. So that means it would be D. Why is 4 the initial term? So pretty much what this, let me erase some of this and it'll make more sense. So you're starting at 4 here, right? You can start at any term as the initial term. But if you subtract 3 from the root, that means you'd be going back 1, back 2, and back 3 onto the y-axis, where our g of 0 is equivalent to. Ah, does this one make sense? Then we're gonna start skipping a few questions so we don't stay here forever. So we'll go to number 9. Because number 9 and 7 are similar, so we'll do 9. So it says it's an arithmetic sequence where b and c are constants. What is the value of b plus c? Struggling with constants, and this is a perfect question for you then to learn this constants. We'll go over this in like a minute because we got a while to go. So okay. So remember, just answer the poll when your answer is done. When you get your answer. or unless you want to type out your like workout and you can point out mistakes, your choice, but always work. Okay, we'll go over this in about 30 seconds. So we'll go over this now. So our first step is to see that we only have two numbers where we have like a clear difference, which would be 5 to 7. So we know this is going by +2, and this is going by -6. So our common difference hence has to be -3, right? And then from there, we can find the rest of our constants. So from here, if we're going subtracting 3, so this would become 23, because 26 minus 3 is 26 minus 3 is 23. And then from there, you can also go the other way. And if you're going down this way, you're subtracting 3. So if we're going this way, we're going to add 3. So we're going to add 3 4 times. So 3 times 4 is 12. We're going to add that to 32, which would be 44. And then 44 plus 23 would be 67. So, C. And yep, you got it right. And it looks like everyone got it right. So, nice. We'll do this one, the calculator active one, because this is just a linear function. So, we'll try 12. And this is calculator active because you're going to need a calculator to solve this. So, I'll show how to do it in Desmos after, but it says, fearing a new computer virus, we have day 1 is simulation day 1. On day 6, we have 750. Day 10, we had 3200. Find how many on day 14. Yeah, hint is geometry. Alright, go over this in like 30 seconds, because with Desmos, it shouldn't take that long, so. G10 is equal to 3200. And that means we have two coordinates, which would be 6, 750, and 10, comma 3200. So if we switch over to Desmos, which should have switched over, and we type table, 6, 10, 750, 3200. We click this button to add a regression. We make it an exponential, because that's what geometric is similar to. We're gonna bring this equation down. We're gonna say change it to f of x. Let's say f of 14, which gives us 13,653. Hence, that would be C. And it says to the nearest whole number. So, that would be C. Any questions about how to use Desmos for this, or the logic behind this? Um, 750. It's supposed to be 750. It's just day 6 is 750. Meant to be 750. It's supposed to be 0. Not very good at drawing them. So, uh, s- uh, so the next part is moving on to exponential functions, and solving them. So A represents our initial value, and B represents the common ratio. Um, it could work. Yeah, it should work. So an exponential function has the general form a times b to the x, where b is greater than 0. And a and b are constants, with a never being equal to 0 and b never being equal to 1. Because if that was the case, it would not work anymore. And exponential growth is when a and b are greater than 1, and a is greater than 0. And exponential decay is when a is greater than 0 and b is between 0 and 1. And exponential functions are always increasing or always decreasing, or they have no relative extrema. And they're always concave up or concave down, so they have no points of inflection. And their end behavior is it's going to be going towards infinity, negative infinity, or 0 without any shifts. So let's try example 3. And remember that an exponential function has, for the x values, it has a constant rate of change. And for the y values, it increases proportionally. Y values, it increases proportionally. So that's my hint for this one. And I'll give about like a minute or two to solve this. I remember we're not doing sequences anymore, so it's now linear, quadratic, exponential, and none of these. There's no arithmetic or geometric anymore. So we're off our, yeah, okay. No problem. Alright, so we will start this. We'll go over this. So as we see, our x values are increasing proportionally. So they're going by +5 each time. So it could be any of these three. And then our y values are going by 2, 4, 8, and 16. And if you see, our values are increasing by multiples of 2. Hence, it's exponential. Any questions about that? And now it's done. I have no questions. We'll go to the next one. 13. So describe the end behavior of f. So pretty much my recommendation would be to graph this out. I see it. So we have f of x, and we're saying that it's decaying because it's less than 1. So we're going to be decaying, and it's positive, so it's going to be like this. And then from there, we see it says negative infinity, which is going towards positive infinity. So we know it's not this or this. And then from there, this is just going towards the x-axis is going towards infinity, and it's going towards 0 because of the asymptote over here. So it would be D. For this one, similar idea, you would graph it out. We know our exponential function looks like this when it's growing, but now we flip it over the y-axis. So this would be this. So now it's decaying. It's still increasing. So now we're going to look at the answer choices. But first look at this, and it's going towards negative infinity, so that's this direction, in this direction, and it's going towards 0, so it can't be these two. And then our y values are going towards negative infinity, so boom. Any questions about these two end behavior ones? I'm gonna guess there's no questions, so we'll continue on. So for 21, I will give about a minute or two to solve this. Okay, we'll give it around like 20 seconds. Okay, two answers, and you both chose D, and that's right. And it's because you're multiplying by 3, so it means you're growing, so it can't be these two. And it can't be decay, because you're growing, so. 27 and 28. I'll put a poll for this real quick. And these are similar to just graphing. Just graph them, and it should be easy. Alright, I'll give another minute or two for about 27 and 28. Alright, so for 27, we have an exponential function, so that means it's increasing, but now it's flipped, so it's negative, so we're gonna point it downwards, which means the function is always decreasing. And it's always concave down, because if you look at it, it's concave down. For this one, we know this is decay, so it's gonna be looking at this, but then we're flipping it. So we're gonna flip it over the x-axis, and then this is always increasing, but it's also concave down. So hope that made sense for both of you. Or for all of you. There's no questions, then we'll continue on. Okay, I'll do 33 and 35 at the same time. So let me zoom out. Oh, it's too much. I think this should work. That works. So I won't put any more polls because it's not that many people. So just spoiler answers from now on. So I'll give until 47 for these two questions. Okay, so the answers are, let's say, the answers are C and C. And for the first one, I hope you see that this goes from 1 and the second one is 3. So it goes from 1 to 2, so it means it's multiplying by 2 each time. So that's for that one. And it's exponential because the output values are proportional. For this one, it's exponential because, for first of all, for these explanations, quadratic because the output values are proportional. That's a false reasoning. And for this, it's the same reason because it's not the average range can be given by linear function. So that's also false. And between these two, as you see from here, the values go from about 10 to about like 7.5. For the input to be proportional, if the input is proportional, it's log. If the input is proportional, it's log. If the output value is proportional, it's exponential. That makes sense. Can we see an algebraic example? Yeah, we'll go to the algebraic example. But we'll go to them soon. All right. Now we're on to the algebra part of the exponentials. So we have 3 really important properties. The product, which is just 2 values multiplied or exponents added. The power property, which is 2 power, an exponent to the power of itself would be multiplying. And if it's negative, it goes to the denominator. And an important idea is every horizontal translation is equivalent to a vertical dilation. And you will see this multiple times, including in 37. So we will zoom back in. So for this first one, I'll walk through these next few ones so then we can get to some harder ones. But so for this first one, we would go 3 to the 4 times x times 4 to the 2. And then from there, it would be 3 times 4 to the 2 times 4 to the x. 3 times 16 times 4 to the x, which would be 48 times 4 to the x. So B. And this is because of this property, the product property, which pretty much just says you multiply these two by themselves instead of adding them if you add them. For this one, it's a really similar idea. We know it's not adding, so we can take this out. And it would be 4x times 4 to negative 2. And 4 to negative 2 is the same thing as 1 over 16 times 4 to the x. If do these both make sense? Like the idea behind them. You'll have more to solve as we go through. If there's no questions, we'll keep going. So I'll let you solve this one. It says the graph of function f is a horizontal dilation of y is equal to 3x, and f of x is equivalent to the square root 3 of x. Which of the following could be an expression for f of x? So I will make a poll for this real quick. We got two answers. And it is A. And it's because if you make square root 3, that would be 3 1/2 the x. And it would be 3 1/2 the x. Or 3 divided by x divided by 2. Now exponential modeling. And it's can be constructed if we're given either the common ratio and the initial value or two input output pairs. And we can find the initial value and the base common ratio with these two pairs, or using Desmos in the TI-84, which is the easiest way to do them. And you'll do this for FRQ2 on the AP exam. So I will give like a few minutes to solve this, like a minute, but I will make a poll again. Alright, so for this one, the way you do this is you're saying that it says D is equal to 7W, so we're going to plug that in to this. So this would be 0.5 times 7W divided by 3.8. And then we're going to bring down the 7 into the thing using this rule that we did over here, the power property. So it would be a to the 0 times 0.5 to the 7, W divided by 3.8. For 48, it is a similar property, and we're saying that it says a month is a 12th of a year. You're saying a month is equal to 1/12 of a year. So that means 12 months is equal to a year. And it says that it's increasing by 2.9% each month. So because of that, we're not going to use the division ones, because that means you'd be doing it every year. And then from there, it says it's increasing by 1.29. So this would be decreasing, so it would be D. For 49, it would be you're going down by 3 each time. So you're dividing by 3 each time. And you're increasing by a value of 1 each time. Which means you would be C, because this would be our common ratio of 1/3. And we would be starting at 324. And then now on to the appropriate models and residuals. So we have 3 types of graphs we've learned so far: the linear, the quadratic, and the exponential. A linear model shows constant rate of change. A quadratic model shows that rates of change that are either increasing or decreasing at a constant rate, and they usually follow a U-shaped pattern. And exponentials show an exponential model where output values are roughly proportional, and each successive output is the result of repeated multiplication. And residuals are pretty much the error from when you find the regression, and it's calculated based off actual minus the predicted, or y minus y hat, where hat beats predicted. And we use a residual plot to calculate the appropriateness of a model. And if it's appropriate, that means the residual plot should appear without pattern. And if you see a pattern, that means it wasn't appropriate. So for 50, we see there's a quadratic pattern, so that means it is not appropriate because it shows a clear pattern. From there, we see that a set of data was used to create a linear, a quadratic, and exponential regression model. We see this has a pattern. We see this also has a pretty clear pattern, but this is like all over the place. So we know we want it to be exponential. From there, we see that it says a set of data and the linear regression model follows with these data points, which is residual for the data point P. And we see that our actual is up here and we see our predicted is on the line and our actual is over here, which means it's negative because our actual is less than our predicted. So it would be negative. From there, we would see that this one says P and Q are labeled and what's true about P and Q. And we see that they have different signs because they're on opposite sides of the predicted value. So we know it's not A or B. And then from C and D, we're looking for the absolute value, which is the distance from the regression, which would be Q is the greatest. So it would be D. And now moving on to 2.78, which is composition of functions and inverse functions. So we're first going to sketch an inverse function, we're going to list the key points and create a table by switching the x and y values and plotting them. So we have -2 as x and -1 as y. So we're going to flip that and put it up over here. From there, we're going to go, our x is -1 and our y is 2. So it's going to go x is 2 and y is -1. This is going to go 1 to 2, and this is going to go 4 to 3. And if we graph it, we see that looks like this. And if you do a graph through y is equal to x, you see that it's a reflection for every single point. And is the original relation a function? It is a function because it passes the vertical line test at each point. And is the inverse relation a function? It is not a function because it doesn't pass the vertical line test at around like 1.5. So now we're going to do some function composition, which is 2.7. So for this, we're going to say, it's saying h of x is equal to g of f of x. What is h of 9? So we're going to say h of 9 is equal to g of f of 9. F of 9, so if you go to x, would be 5. So then we're doing g of 5. G of 5 is when we go from 5 to 4. So this would be equal to 4. From there, we're saying k of 3. So this would be k of 3 is equal to f of g of 3. G of 3 would be 5. And f of 5 would be 8. And then from there, we're doing some composition of functions. So now we're plugging in f of x into g of x. So we're going to say 2x minus 1 squared plus 3 to the 2x minus 1. This would be 4x squared minus 4x plus 1 plus 6x minus 3. And then if you simplify, it would be 4x squared plus 2x minus 2. From there, now it says k is equal to the inverse of this. And this is our graph. So we're looking at the inverse of it. And we're saying the minimum value. And if you remember, we're switching x and y. So now we're going from y is equal to x to x is equal to y. So we're flipping our x and y values. So our minimum y value is found at -4. But now we're flipping it, so our minimum x value would be -3. From there, we're doing now inverse tables. So we're going to say what g of 4 is. G of 4 is 7. And f inverse of 7. So we look at where 7 is, and that means we get 2. From there, we have g of -1, and this is looking at f of 2, which should be 7. And the inverse of that would be 4. And then we're looking at the inverse of 7. So we're going to go to 7, and we're going to go back to find x. So that would be 2. And then from the inverse of g of 2, we're going to go back, which means we'd be looking at 7. From here, we're doing 75, which is like an algebra question. and we're just trying to find the inverse of it. And we do that by switching x and y. So we're going to say x is equal to 2y minus 3, y plus 4. We're going to first multiply this out to simplify this. Equals 2y minus 3. Xy plus 4x is equal to 2y minus 3. We're gonna add 3 to the side, so this would be xy plus 4x plus 3 is equal to 2y. We're gonna subtract xy, so this would be 4x plus 3 is equal to 2y minus xy. We're gonna multiply both sides by y, so we can get x to be positive. So now we're going to get negative 4x minus 3 is equal to negative 2y plus xy. We're going to factor a y on this side, so this would be x minus 2 is equal to negative 4x minus 3. We're going to divide by x minus 2, which would get us negative 4x minus 3 divided by x minus 2 equals y, which lines up with C. Any questions about this? Now we're going to move on to logs. And logs pretty much are the inverse of exponentials. So we're going to first plug in log 8 of 2. And if you remember, we're going to say 2 to what power? We're going to say 8 to what power equals 2. And that would be 1/3. Because if it was negative, it would become a fraction. And if it was to the power of 1/4, we would get a decimal. And if it was 1/3, that's a perfect of 2. So that would be that. For 78, it would be log 3 of 1/9. So it would be log 3 of 1/9. We would say 3 to what power gets us 1/9, which would be negative 2. Because that's the only way to get fractions, by putting exponents to the power of negative, which is our negative exponent rule from before. Because 3 to negative 2 would be equal to 1/9. From there, we're saying what input value in the domain of h yields an output value of 1/2. So now we're going to be saying log 4 of x is equal to 1/2. We're going to say x to the power of something equals 4 to the 1/2. 4 to the 1/2 is the same thing as saying the square root of it. So this would be 2 is equal to x, which means 2 is our answer. And this is because anything to the power of a fractional exponent is the square root. And then we can also apply that to back here where we said 8 to the cube root be equal to 2. From there, we have 80, which is pretty much just setting the two equations equal to each other. So you're saying log 10 of x is equal to 1. We can raise both sides to the power of 10, and this would be 10 to the 1 is equal to x, which means it would be equal to 10. From there, we have our exponential and we have a log. And if we remember, exponentials and logs are inverses of each other, which means we have to flip our x and the y values. So we're going to flip the x and the y values. So it would be 1/8 and negative thirds. So it would be b, and 16 and 4. From here, we're dividing by negative 2 each time. And we're adding 2, so this follows our logarithmic pattern because our x is proportional and our y is constant. And that would line up with C because it says inputs are changing proportionally as output values increase in equal length intervals. For 85, it's a similar idea, but now we're multiplying by 3 each time, and we're adding 10. So that means it's an exponential because our output values are changing proportionally. and our input values are changing by equal length intervals. Um, sorry. So from now, we know we're looking at a graph. So now we're looking at graphs pretty much. And if you remember, log always looks like this. So log goes like this, and that means it's also increasing, but it's also concave down. So this would be this. And then we're gonna do another graph. Now we're flipping it, so it's gonna go look like this. And now it's decreasing and concave up. For here, it's the same thing as the other one, but now we just have a shift 3 upwards. So it would be decreasing and concave up. For 89 through 90, we're going to be doing limits. And limits pretty much are the same thing. We're going to graph it. And then from there, we're going to say, we're looking at the limits. So we're going to look at the first choice. It says the limit as it approaches infinity is 0. That's false because we're going to be increasing still. This one says infinity is infinity. That is true. Infinity is non-negative infinity. And as it approaches 0 from the right, it's going to infinity. That's false. So we know it's B. For this one, we know it's negative 3 log 2 of x. So we will be looking at a function that looks like this. And then from there, we know we look at infinity, and it's not approaching 0 because there's no horizontal asymptote, so it's not this. This is going towards negative infinity now because it's flipped, so it can't be this. So that means it's this. And this needs to be going to positive infinity for this to be true. And now we have our properties of logs, which is log b of x of y is equal to log b of x plus log b of y. So pretty much multiplication becomes addition. Quotient pretty much means division becomes subtraction. And product means if you have an exponent on the inside, it comes to the outside as a whole number or as a ratio. So we're first going to split this up into ln of 4 plus ln of x to 3. Which should be 3 ln of x plus ln of 4, which should be this. For this one, we would do a similar thing where we would say it'll be log 2 of 5y squared minus log of 2 of z3. Then we're going to split these again. So this would be log 2 of 5 plus log 2 of y squared minus log 2 of z to the 3. And then we would bring out the exponent. So this would be log 2 of 5 plus 2 to the log 2 of y minus 3 to the log 2 of z, which would line up with C. And now we're going to use a formula called change of base, which we'll go over more later. So pretty much it would be C. And that's the reason is because the formula would be you pretty much put your inside on top, you put your base on the bottom, and you can take the log of the same numbers. So you can take a log of 10 of both of them. You can take ln of both of them. You can take log 2 of 9, log 2 of 4. You can take whichever log you want. But you just need the inside argument to be on top and the base to be on the bottom. For 101, it would be using our log rules. And pretty much it says we're plugging in w. So this would be 2 times ln of w minus ln of z, which should be w squared divided by z ln using our, and we're just going backwards from our old rules. For this one, we're going to be using multiplication. So we're saying log 2 of 6 times added to log 2 of x, which should be a vertical translation because we're adding it on the outside. And now we're going to move on to logarithmic and exponential equations and inequalities. And it's the same properties from before, but now we can convert, which means a is equal to b to the power of c is the same thing as log to the b of a equals c. And we're gonna first isolate the exponential log, and then we're gonna convert it to the other form if needed, and solve for the variable and simplify and or round answer as directed. So if we're working with multiple logs, we're gonna use our log properties, and then we're gonna set it equal to xy. And if we, for example, if it says log x of y equals z, it does not mean x plus y equals z. It means x times y is equal to z. And we need to check for extraneous solutions always. So we have to always plug in numbers at the end of our solutions to check for solutions that actually aren't solutions. So let's try with this one. So I'll give like a minute or two for this. So for this one, we're gonna use our log properties, which say adding is multiplying. So we're gonna say 3 to the x plus 4 log is equal to log of 5x minus 2. And then we can take the 10 of the power of both on the same sides, or we can just cancel logs. So this would be 3x plus 12 is equal to 5x minus 2. We're going to do some algebra, so this would be 2x is equal to 14, and x is equal to 7. And if we plug it in, this works, and this works. So that means 7 is a solution. So x is equal to 7 is a solution of the set. For this one, it's asking us to find what are all the x coordinates of the points of intersection and that pretty much means set them equal to each other. So we're going to set them equal to each other. We're going to say log 3 of 2x minus 3 plus log 3 of x plus 4 is equal to log 3 of 8x plus 2. And then we're going to combine these. So this would be 2x minus 3 of x plus 4 of log 3 is equal to log 3 of 8x plus 2. And now we will simplify by raising both sides to the power of 3. So that would be 2x minus 3 to the x plus 4 is equal to 8x plus 2. We're going to simplify this, which would make 2x squared minus 3x plus 8x minus 12 equals 8x plus 2. We can cancel 8x from both sides, subtract 2. 2x squared minus 3x minus 14 is equal to 0. You can factor that to 2x minus 7 is equal to x plus 2, which is equal to 0. And that means x is equal to negative 2 and 7 over 2. And if we plug in negative 2, we would get a negative solution here, which isn't allowed because our domain is always greater than 0. Greater than or equal to 0. So that means x equals 7, 2 is our only solution. And so now we're going to find the inverse. We found inverses before, but now we're going to do it with exponentials and logs in general form. So now we're just going to switch to x and y and then solve. So we're going to say x is equal to 2 to 3y, y plus 4 minus 15. We're going to add 15 to both sides. So this would be 3 to the 2, y plus 4. We're going to divide by 3. So this would be x plus 15 divided by 3 equals 2 to the y plus 4. I'm going to take the log of both sides. So this would become log 2 of x plus 15 divided by 3 equals y plus 4. Subtract 4. This would be y is equal to log 2 of x plus 15 divided by 3 minus 4. And we can write it in form, so this would be, boom, is equal to log 2 of x plus 15 divided by 3 minus 4. And that's our final solution. From there, we're going to find where k of x is equal to 1. It's saying k of x is equal to the inverse of this function. So we first have to find the inverse of the function. So we're going to say x is equal to 3y plus 1 minus 2. X plus 2 is equal to 3y plus 1. From there, we're going to take the log of both sides. This would be log 3 of x plus 2 is equal to y plus 1. We're going to subtract 1, so that means h of negative 1x would be equal to log 3 of x plus 2 minus 1. And then we're going to set it equal to 1. So 1 is equal to log 3 of x plus 2 minus 1. 2 is equal to log 3 of x plus 2. Take the power of both sides. This would be 9 is equal to x plus 2. X is equal to 7. Any questions? If there's no questions, we'll continue. So this is change of base, which is just log b of a is equal to log x over a log x of a divided by log x of b, which means the inside goes to the top and the base goes to the bottom. And you can choose what x wants to be. So we're going to solve this. And this is a long one. So our first step is just to simplify. So log 2 of 3x plus 2 minus log of 2 to the x divided by log 2 to the 4, which is equal to 3. And then from there, we're going to simplify this. So this would be log 2 of 3x plus 2 minus log 2 of x divided by 2 equals 3. Now I'm going to set that as log 2 of 3x plus 2 minus 1/2 of log 2 of x equals 3. Now we're going to put this on the inside, which means log 2 of 3x plus 2 minus log 2 of the square root of x equals 3. From there, we're going to combine. So this would be log 2, or we're going to condense, same thing, which would be 3x plus 2 divided by the square root of x is equal to 3. I'm going to raise both sides to the power of 2 to cancel out the log. So that would be 3x plus 2 is equal to the square root of x equals 8. From there, we're going to simplify that a bit more. So that would be 3x plus 2 equals 8 square root x. And now we're going to do a little bit of substitution. And we're going to say u is equal to the square root of x, and x is equal to u squared. So we're going to plug that numbers in. So that'd be 3u squared plus 2 is equal to 8u. 3u squared minus 8u plus 2 equals 0. We factor that to get 3u minus 2, u minus 1 equals 0. From there, we're going to solve for u, which should be u is equal to 1 and u is equal to 2 over 3. From there, we're going to plug this back into x is equal to u squared, means x is equal to 1 and x is equal to 4 over 9. And if we check and plug it in, 4 over 9, and that works, so that means both of these are solutions. None of them are negative. And if you ever want to solve exponential equations, this is how you would solve an inequality. So we're going to go step by step. No problem if you gotta leave. It'll be on YouTube after, so So if you ever want to solve one, you would first start with the discriminant, and it's negative, and we would check, that means x is equal to -3, so that means our solutions have to be greater than this. From there, we're gonna condense the logs, and then we're gonna rewrite them, so we're gonna take to the power of 10 both sides, and then we're gonna rewrite it like this, and then we're gonna do some sign charts, and we're gonna check that it has to be greater than -3, and that gives us our solution as this. And then from there, we're gonna do the same thing here. We're gonna set them equal to each other, and we're gonna compare. So as you see, we would set them equal to each other. We know that it has to be greater than this, and it has to be greater than or less than this. I'm gonna subtract, we're gonna solve. We're gonna solve for it. I'm gonna say it's less than 0. Take to the e of both sides, but e to the 0 is still 1. We're gonna solve. We're gonna simplify. We factor this to be x minus 3, x plus 3. We're gonna check our solutions, and it would be this. For 125, we're doing something similar, and we're saying it's 9x minus 1 and this, and we're saying where h of x is greater than 0. And it says this is a composition of functions. So we're plugging in f of x to g of x. So we're going to say log 3 of 9x minus 1. We could take out the x minus 1 to the numerator. So x minus 1 log 3 of 9. And log 3 of 9 is 2, so this would be 2x minus 2. And we're saying it's greater than 3. So we're going to say it's greater than 3. And then we're going to solve by adding 2 on both sides. 2x is greater than 5. X is greater than 5 over 2, which should be B. Any questions? So our last topic is semi-log plots. So a semi-log plot is when one of the axis is logarithmically scaled, and AP Precalc will be only doing the y-axis. And when a semi-log plot where the y-axis is logarithmically scaled, exponential functions will appear linear. So if we look at this, we see that it appears exponential. But then after we put it on a thing where now it's 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, it looks pretty linear. And important note, we're not changing the actual y values, we're just changing what the vertical axis looks like. And then given the exponential model, if you want to try to find a linear model for the regression line, it would be y is equal to the log n of b, so our ratio, x plus log n of a, our constant value. And n is our base used for scaling. So for 134, where the vertical axis is logarithmically scaled, we know it's saying what could f of x be. We already know it's not the two linear ones, because this is just a representation of it. It's not asking for what this is. Our equation f of x. So for f of x, we can see it's decreasing, so it's not increasing. So that means it would be a, because if we think about it like this would be an increasing function. But this has a negative slope, which means it's like this. For this one, we know it's still exponential for that same reason. And it's also increasing. And we know that if an exponential function is increasing, it is concave up. Oh, wrong, I circled the wrong one. It's mentioned concave up. And then finally, last question of the day. We see that our residual has a pattern. So our model was not appropriate, so we know it's not these two. And then it says It's linearly scaled as well as the residual plot that results when the regression P is used to model given data. And it talks about the regression, which means the model P is linear. Because it's talking about the regression, not the actual equation. What YouTube channel will this be on? This will be on 5hive.org, I think, is the YouTube channel. I'll send that link one sec. It's up, and that is the end of the lecture. So, unless you have any other questions, that is the end of today's lecture on Unit 2. And this will be posted on YouTube by like probably tomorrow or the day after. So, thank you for staying for this last 1 hour, 30 minutes.